Now moving ahead with the question of binomial here again. See, is it a question of binomial is the question. See, I deliberately gave this question under this chapter because of presence of this term RC3. So let's start. So we have to evaluate the series, which is summation of over R, where R goes from 3 to infinity, and summation over RC3 into 3 raised to the power R by R factorial. Okay, now if we solve it, RC3 is, simplify it. See, that's what I will suggest, by 3 factorial into R minus 3 factorial into 3 raised to the power R by R factorial. So this term at least gets vanished. Okay, now we have the answer. See, it has nothing to do actually with the binomial coefficient or binomial theorem except for the presence of this binomial term here, binomial coefficient here. Okay, but still, as I said, I deliberately gave this question because see, we have to keep our mind open to use anything anywhere. Okay, so now if you look at it, so what we have, so this is like if I write 6 factorial, then this is rather not 6 factorial, it will be 1 by 6. But why should I write 1 by 6? I can cancel out 3 here, so it will be 1 by 2. Okay, 3 raised to the power R minus 1 over R minus 3 factorial. Clear? Now see, just open the series, bachon. Just open it. See, that's what I always suggest. If we don't have the direct formula for any summation, so to take note of the like that series, or to just observe the series, I always suggest once open the series. So let us once open it. So what do we mean? Just by substituting the values of R here, we start with R is equal to 3. So it's 3 square by 0 factorial, 3 cube by 1 factorial, 3 maybe 3 raised to power 4 by 2 factorial, 3 raised to power 5 by 3 factorial. I don't think we need more terms here until infinity. Okay, now where are we heading to? Okay, acha, one more thing, let's take 3 square common. Okay, so we have 1 over 0 factorial. Now I think all of you can see it happening, or see what are we getting here directly. Which series is it? So that's nothing but the series of exponent or exponential series. So this is 9 by 2 into e cube. Okay, so if you wish, I can write it here, bacho, where we should know that e raised to the power x is 1 by 0 factorial plus x by 1 factorial plus x square by 2 factorial, x cube by 3 factorial, and so on and so on. So just substitute x by 3 and you get this as the answer. So it's a simple question. The only thing is we have to keep our mind open for everything. So it may happen that looking at the question in first instance, we feel that it's a question of binomial related to binomial theorem, binomial coefficient, but no. It's for me, the way I solved it, it's more a question of exponential series here, bachon.